Welcome to our exploration of green building design where innovation meets sustainability. As the world faces increasing environmental challenges, architects and builders are reimagining how we construct our spaces. Green building design is more than just a trend, it's a movement toward creating structures that are energy efficient, environmentally friendly, and healthy for their occupants. In this video, we'll uncover the latest innovations driving sustainable architecture, from cutting-edge materials to smart energy systems. Let's begin our journey by understanding what makes a building truly green and why these advancements are so crucial for our future. Green buildings are designed to reduce their overall impact on the environment and human health. This involves careful planning, from site selection to material choice and energy use. The goal is to minimize waste, conserve resources, and create healthier living and working spaces. Green buildings often incorporate renewable energy sources, efficient water management, and non-toxic materials. By focusing on sustainability at every stage, these structures set new standards for responsible architecture. Next, we'll look at the core principles that guide green building design and how they shape the built environment. The heart of green building design are several key principles: energy efficiency, water conservation, indoor environmental quality, and the use of sustainable materials. Energy efficiency means reducing the amount of energy a building consumes, often through insulation, smart systems, and renewable sources. Water conservation involves strategies like rainwater harvesting and low-flow fixtures. Indoor environmental quality focuses on air, light, and comfort, while sustainable materials are chosen for their low environmental impact. These principles work together to create buildings that are both functional and environmentally responsible. One of the most exciting areas of green building design is the development of innovative materials. From recycled steel and reclaimed wood to advanced composites and bio-based products, these materials reduce the environmental footprint of construction. For example, bamboo is a rapidly renewable resource, while recycled glass and concrete help divert waste from landfills. These new materials not only support sustainability but also offer unique aesthetic and structural benefits, allowing architects to push the boundaries of design while protecting the planet. Energy efficiency is a cornerstone of sustainable architecture. Modern green buildings use a range of systems to reduce energy consumption, from high-performance insulation and triple-glazed windows to smart lighting and HVAC controls. Solar panels and wind turbines are increasingly common, allowing buildings to generate their own renewable energy. These systems not only lower utility bills but also reduce greenhouse gas emissions, making a significant contribution to environmental protection. Let's explore how these technologies are integrated into today's green buildings. Water is a precious resource, and green buildings are designed to use it wisely. Techniques like rainwater harvesting, graywater recycling, and low-flow plumbing fixtures help minimize water waste. Landscapes are often planted with native species that require less irrigation, further reducing demand. These strategies not only conserve water but also lower operating costs and support local ecosystems. By integrating water-saving technologies, sustainable architecture ensures that every drop counts. Healthy indoor environment is essential for occupant well-being. Green buildings prioritize air quality by using non-toxic materials, proper ventilation, and air filtration systems. Natural lighting and views of nature are also emphasized, creating spaces that are comfortable and uplifting. By focusing on indoor environmental quality, sustainable architecture supports both physical and mental health, making buildings better places to live and work. Technology plays a vital role in advancing green building design. Smart systems monitor and control lighting, heating, cooling, and security, optimizing energy use and comfort. Sensors can adjust settings based on occupancy or daylight, while building management software provides real-time data for efficient operation. These innovations make buildings more responsive, reducing waste and enhancing sustainability. As technology evolves, smart buildings are becoming the new standard for sustainable architecture. Integrating renewable energy sources is a hallmark of green building design. Solar panels, wind turbines, and geothermal systems are increasingly used to power buildings sustainably. These technologies reduce reliance on fossil fuels and lower carbon emissions. By generating clean energy on-site, green buildings can even achieve net zero or positive energy status, producing as much or more energy than they consume. This shift is transforming how we think about energy in the built environment. Passive design is all about harnessing natural resources to reduce energy use. This includes orienting buildings for optimal sunlight, using thermal mass to regulate temperature, and maximizing natural ventilation. Shading devices and high-performance windows help control heat gain and loss. By leveraging the local climate, passive design strategies create comfortable interiors with minimal mechanical intervention. These time-tested techniques are being refined with modern technology for even greater efficiency. Green roofs and living walls are innovative features that bring nature into urban environments. Green roofs are covered with vegetation, providing insulation, reducing stormwater runoff, and creating habitats for wildlife. Living walls or vertical gardens improve air quality and add beauty to building facades. These features not only enhance sustainability, but also contribute to the well-being of occupants and the surrounding community. As cities grow denser, integrating greenery into buildings is more important than ever. Maximizing natural light is a key aspect of sustainable architecture. Daylighting strategies use windows, skylights, and light shelves to bring sunlight deep into buildings, reducing the need for artificial lighting. This not only saves energy but also creates bright, inviting spaces that support occupant health and productivity. Careful design ensures that daylight is balanced and glare is minimized, making interiors comfortable throughout the day. Sustainable architecture starts with thoughtful site selection and development. Low-impact strategies include preserving natural habitats, minimizing land disturbance, and managing stormwater on-site. Permeable paving, green infrastructure, and careful landscaping help maintain local ecosystems and reduce environmental harm. By respecting the natural context, green buildings blend seamlessly with their surroundings and support biodiversity. Construction generates significant waste, but green building design aims to minimize it. Strategies include prefabrication, modular construction, and recycling of materials. By planning carefully and using resources efficiently, builders can reduce landfill waste and lower the environmental impact of projects. These practices also save time and money, making sustainable construction a smart choice for both the planet and the bottom line. Life cycle assessment, LCA, evaluates the environmental impact of a building from cradle to grave. This includes raw material extraction, manufacturing, transportation, construction use, and eventual demolition or recycling. By considering the entire life cycle, architects can make informed choices that reduce a building's overall footprint. LCA is a powerful tool for guiding sustainable design decisions and ensuring long-term environmental responsibility. Green buildings are often recognized through certifications like LEED, BREEAM, and WELL. These standards set benchmarks for sustainability, covering areas such as energy use, water efficiency, materials, and indoor quality. Achieving certification demonstrates a commitment to best practices and provides assurance to occupants and investors. As these standards evolve, they continue to raise the bar for sustainable architecture worldwide. Biophilic design connects people with nature through architecture. This approach incorporates natural materials, patterns, and views, as well as indoor plants and water features. Biophilic elements have been shown to reduce stress, boost creativity, and improve well-being. By bringing the outdoors in, sustainable buildings create environments that nurture both people and the planet. Adaptive reuse involves repurposing existing structures for new uses, rather than demolishing and rebuilding. This approach preserves cultural heritage, reduces waste, and saves resources. Examples include converting warehouses into offices or factories into apartments. Adaptive reuse is a creative way to meet modern needs while honoring the past and supporting sustainability. Urban green spaces, such as parks, gardens, and green corridors, are essential for sustainable cities. These areas provide recreation, improve air quality, and support biodiversity. Integrating green spaces in urban planning enhances the quality of life for residents and helps cities adapt to climate change. Sustainable architecture often includes rooftop gardens, courtyards, and landscape plazas to bring nature closer to people. Net zero buildings produce as much energy as they consume, while positive energy buildings generate even more. Achieving this requires a combination of energy efficiency, renewable energy, and smart design. These buildings are at the forefront of sustainable architecture, demonstrating what's possible when innovation and environmental responsibility come together. As technology advances, net zero and positive energy buildings are becoming more accessible and affordable. Resilient design prepares buildings to withstand the impacts of climate change, such as extreme weather, flooding, and heat waves. Strategies include elevating structures using flood-resistant materials and designing for passive cooling. By anticipating future challenges, resilient buildings protect occupants and investments while supporting long-term sustainability. This proactive approach is increasingly important as climate risks grow. Sustainable architecture is most successful when it involves the community. Engaging residents, stakeholders, and local experts ensures that buildings meet real needs and reflect local values. Participatory design processes foster a sense of ownership and encourage sustainable behaviors. By working together, communities and designers can create spaces that are both innovative and deeply rooted in place. Making green building accessible to everyone is a key goal of sustainable architecture. Affordable green housing uses cost-effective materials and efficient systems to lower construction and operating costs. These homes provide healthy, comfortable living environments for people of all incomes. By prioritizing affordability, sustainable design can have a broader positive impact on society. Green buildings are often located near public transportation, bike paths, and pedestrian routes. This reduces reliance on cars, lowers emissions, and encourages active lifestyles. Providing bike storage, electric vehicle charging, and easy access to transit supports sustainable mobility. By integrating transportation planning with building design, architects help create more connected and environmentally friendly communities. Using healthy materials is essential for both people and the planet. Green buildings use products that are low in volatile organic compounds, VOCs, free from harmful chemicals, and responsibly sourced. These materials improve indoor air quality and reduce health risks for occupants. By prioritizing health, sustainable architecture creates safer, more comfortable spaces for everyone. Sustainable buildings incorporate efficient waste management systems, both during construction and throughout their use. This includes recycling, composting, and waste-to-energy technologies. By reducing landfill waste and promoting resource recovery, green buildings support a circular economy. Effective waste management is a key part of minimizing environmental impact and building a more sustainable future. Advanced water management systems help green buildings use water efficiently. Smart irrigation, leak detection, and water reuse technologies ensure that every drop is used wisely. These systems are often monitored and controlled digitally, allowing for real-time adjustments and optimization. By embracing smart water management, sustainable architecture conserves resources and reduces costs. Green buildings are designed to be flexible and adaptable, meeting changing needs over time. Movable walls, modular furniture, and multipurpose rooms allow spaces to evolve as requirements shift. This adaptability extends the life of buildings and reduces the need for costly renovations or new construction. Flexible design is a hallmark of sustainable architecture, supporting long-term usability and resource efficiency. Prefabrication and modular construction are revolutionizing the building industry. By assembling components offsite, these methods reduce waste, speed up construction, and improve quality control. Modular buildings can be easily expanded or reconfigured, supporting sustainability and adaptability. These innovative approaches are making green building more efficient and accessible than ever before. Building automation systems, BAS, integrate and control various building functions such as lighting, HVAC, and security. These systems use sensors and software to optimize performance, reduce energy use, and enhance comfort. Automation is a key driver of efficiency in green buildings, enabling real-time adjustments and continuous improvement. As technology advances, BAS are becoming more sophisticated and user-friendly. Landscaping plays a vital role in green building design. Sustainable landscaping uses native plants, efficient irrigation, and organic maintenance practices to conserve resources and support biodiversity. Green spaces also provide shade, reduce heat islands, and create pleasant outdoor environments. Thoughtful landscaping enhances the sustainability and beauty of any building project. Facade of a building is its face to the world, and innovative designs can greatly improve sustainability. Dynamic facades use shading devices, operable windows, and responsive materials to control light, heat, and airflow. These features reduce energy use and enhance occupant comfort. Creative facade solutions are helping green buildings stand out while meeting high environmental standards. Urban areas often experience higher temperatures due to heat-absorbing surfaces. Green buildings help mitigate this effect through cool roofs, green roofs, and reflective materials. Planting trees and increasing green space also lowers temperatures and improves air quality. These strategies make cities more comfortable and resilient in the face of climate change. Lighting is a major energy consumer in buildings, but sustainable solutions are changing that. LED fixtures, daylight sensors, and smart controls reduce energy use and improve lighting quality. These technologies create bright, efficient spaces that support productivity and well-being. Sustainable lighting is an essential part of any green building strategy. Operating a building sustainably is just as important as its design and construction. This includes regular maintenance, energy monitoring, and occupant education. Sustainable operations ensure that green features perform as intended and that buildings remain efficient over time. By fostering a culture of sustainability, building managers and occupants can maximize the benefits of green design. Heating, ventilation, and air conditioning (HVAC) systems are being transformed by green building innovations. High-efficiency equipment, heat recovery, and demand-controlled ventilation reduce energy use and improve indoor air quality. Smart controls and sensors optimize performance based on occupancy and weather. These advancements make HVAC systems more sustainable and responsive to occupant needs. Investing in green building design often leads to long-term savings. Lower energy and water bills, reduced maintenance costs, and increased property values make sustainable architecture financially attractive. Incentives and certifications can further improve the economic case. By considering both environmental and economic benefits, green buildings offer a compelling value proposition. Education is key to advancing sustainable architecture. Training programs, workshops, and public campaigns raise awareness of green building benefits and best practices. By sharing knowledge, architects, builders, and occupants can work together to create more sustainable environments. Ongoing education ensures that innovation continues and that sustainability remains a priority. Green building design is a global movement, with innovative projects emerging around the world. Different regions adapt sustainable strategies to local climates, cultures, and resources. From passive houses in Europe to net-zero skyscrapers in Asia, these trends showcase the diversity and creativity of sustainable architecture. By learning from global examples, we can inspire new solutions for our own communities. The future of sustainable architecture is bright, with ongoing innovation and growing commitment to environmental responsibility. Emerging technologies, new materials, and evolving standards will continue to shape the field. As architects and builders push the boundaries, green building design will become the norm, not the exception. Together, we can build a more sustainable, resilient, and beautiful world. Edge in Amsterdam is often cited as one of the greenest office buildings in the world. It features advanced energy management systems, solar panels, rainwater harvesting, and a smart lighting system that adapts to occupancy and daylight. The building's design maximizes natural light and ventilation, creating a healthy and productive environment for its occupants. The Edge demonstrates how innovative design and technology can achieve outstanding sustainability results. Bosco Verticale, or vertical forest, in Milan is a striking example of biophilic design. These residential towers are covered with thousands of trees and plants which improve air quality, provide shade, and support urban biodiversity. The project has become a model for integrating greenery into high-rise architecture, showing how cities can embrace nature even in dense urban settings. Bullitt Center in Seattle is designed to be the greenest commercial building in the world. It features net-zero energy and water systems, composting toilets, and a solar array that powers the entire building. The Bullitt Center's commitment to sustainability extends to its materials, which are free from harmful chemicals. This project sets a high standard for green building and demonstrates what's possible with visionary design. One Central Park in Sydney is renowned for its integration of green walls and rooftop gardens. The building uses a heliostat to reflect sunlight into shaded areas, enhancing natural light throughout the complex. Water recycling and energy-efficient systems further boost its sustainability. One Central Park is a vibrant example of how green building design can transform urban living. As we've seen, green building design is driving a revolution in architecture. Through innovative materials, smart systems, and a deep respect for the environment, sustainable architecture is shaping healthier, more resilient communities. The journey towards sustainability is ongoing, but every new project brings us closer to a greener future. By embracing these innovations, we can all play a part in building a world that thrives for generations to come.